Okay, we are still on densities, but this time around we are going to look at finding densities of mixtures. So when two liquids are being mixed together, what will now be their overall density? It's very easy. Still the same formula, mass over volume, but something will just change a bit. So let's look at this question. It says determine the density of the resulting mixture of 42 grams of alcohol of density 0.7 grams per centimeter cube mixed with 20 grams of water. So what we're going to do here is this. Since it is now a mixture of alcohol and water, and we'll now get the overall density, we can say our density at this point will now be the mass of the alcohol plus the mass of water divided by the volume of the alcohol plus the volume of water involved. We just stretched the formula a bit. Of course, we know the formula still stands at density equals mass over volume. So we just made it look this way to involve the alcohol and the water. So let's see if we have the mass of the alcohol, the mass of water, the volume of the alcohol and volume of water, so that we can easily just fix them in here and do the add up and then divide and get the overall density. So let's do the checking. So mass of the alcohol, is it in the question? Yes, is there 42 grams. Anything in gram or kilogram is your mass. See it, 42 grams of alcohol. So I'm going to write it down, 42 grams. Then the mass of water, is it there? Let's see. Of density alcohol of density 0.7 gram per centimeter cube mixed with 20 gram of water. Okay. So the mass of water is 20 gram. What about the volume of the alcohol and the volume of water? So it is not even in the question. So nothing like any volume here, like something centimeter cube. So they also determine the density of the resulting mixture of 42 grams of alcohol of density 0.7 grams per centimeter cube mixed with 20 grams of water. So they excluded the volume of the alcohol and the volume of water. Anyway, we can get that ourselves. If not, we'll not be able to fix in the volumes here and we'll be stuck here. So this is given and this is given, but this is not given and this is not given. We can find them out by using the formula density equals mass over volume. So let's start with the alcohol first of all. Let's find the volume for the alcohol first. So we can fix here. Then when we are done, we will now find the volume for the water and fix. Then finally do the addition and the division also. So density equals mass over volume. So since we are doing for the alcohol, we are going to now use the density for the alcohol, which is 0.7, and I'll fix it here. And I'll fix the mass for the alcohol, which is 42 grams, so that I can get the volume of the alcohol. Very easy. So density of the alcohol is 0.7, according to the question, equals what's the mass of the alcohol, 42 grams, over the volume of the alcohol. We need that seriously. So we now cross multiply. So we now have V times 0.7, we have 0.7 V equals 1 times 42, divide both sides by 0.7. So if you divide both sides by 0.7, your velocity will now be, let's check, 42 divided by 0.7. It's going to be 60 centimeter cube. And I'm using centimeter cube because they used gram. So if they use gram for the mass, then your volume will be in centimeter cube. If they use kilogram for the mass, then your volume will be in meter cube. So since they use grams, so I finally got in the volume of the alcohol, which is 60 centimeter cube. So checkmate, I've gotten this one. So it's remaining this one. So I'm still going to do the same thing. I'll still use density equals mass over volume, but this time is of water, and this one is of water for water generally. And generally speaking, the density of water is always 1 gram per centimeter cube. Have that at the back of your mind. Do not forget it. Or if you want to convert the 1 gram per centimeter cube to kilogram per meter cube, just multiply the 1 by 1000. So 1 times 1000 gives you 1000 kilogram per meter cube. So have that at the back of your mind, that the density of water is either 1 gram per centimeter cube or 1000 kilogram per meter cube. But because everything here is in gram and centimeter cube, we are going to use this particular density of water, which is 1. So we just fix your density 1 equals to, what's the mass of water? Mass of water is 20 grams. So that's 20 over the volume we need. Then you cross multiply. Volume times 1 is still volume. Then 20 times 1 is still 20. So we have our answer now, 20 centimeter cube. So we can now fix the values now. Let me write it here, 20 centimeter cube for water. So that's how you're going to solve. You find the volume for the alcohol using the density of the alcohol, and then you keep it. And then you now find the volume for water using the density of water, do a little bit of mass cross multiplication, get the value, and then you fix. So everything here is complete. So I can now fix them in here and calculate. So now, let me now fix. So density equals, what's the mass of the alcohol? That's 42 plus the mass of water is 20 over volume of alcohol, we found that one is 60, plus the volume of water, we found that one also, we got 20. So we now say density equals 42 plus 20, that's 62, over 60 plus 20, 80. So if you divide 62 by 80, you get 0.775 gram per centimeter cube. That's the overall density of the mixture. Don't forget why we're using gram per centimeter cube as our unit is because of the other units have the gram for mass, and the volume has a centimeter cube also. So it has to be in gram per centimeter cube. But if you still want to convert to the agreed SI units, we will only multiply by 1000. So to convert 0.775 gram per centimeter cube to kilogram per meter cube, we'll multiply by 1000. So we just have 0.775 gram per centimeter cube times 1000. And of course, if you multiply this by 1000, you get 775. Then you now put your kilogram per meter cube since you multiplied by 1000. That's how to convert. So that's it. That's 3 zeros, 1, 2, 3. That's it. 775 kilogram per meter cube. So very easy. So we're going to do another example under this finding densities of mixtures.